Hi, this is Shelly, and this is my YouTube channel AI Economics. I'm a professor of artificial intelligence, and I teach AI concepts to business management students decoded with a business lens. If you're interested in this content, please do subscribe. Now to today's video. Now this is the fifth part A of my sequence of videos on my in my video sequence developing generative AI applications for business managers. It need not be business managers. It can be anyone who's basically a non-technical audience. All you need to do is know a little bit of Python to get going. Now, the motivation for these videos developed when I saw there was a plethora of videos on YouTube which were like offering to create generative AI applications in 15 minutes. Yes, the coding aspect is actually quite simple. However, I found that there were many concepts which are needed to be known about AI before you can really develop your own applications. So you might at a pinch follow along the tutorials that are there. However, you will not find it easy to generalize the tutorials to your specific case. Now to today's video. Now, in today's video, basically, one of the most important things that methods that to combat the problem of hallucination is retrieval augmented generation. For one of the key components of retrieval augmented generations and the way that large language models functions is vectorization or conversion of text to vectors. Now, to be able to develop generative AI models, you do need to have some understanding of this process. It's a slightly lengthy process because it means delving right back into high school mathematics and vectors. So in the first part of this vector series, I had actually deep dived into what is a vector and had given examples of different types of vectors and broadly explained the definition. This is the second video in which I talk a little bit further about what are the properties of vectors, particularly vector addition and subtraction, which, by the way, is very important for the way the words are handled in natural language processing. And I also talk a little bit about dimensionality, which again is very important in the context of natural language processing. So let's get to it. And just a further point I wanted to make. If you really feel that this content is either not very interesting or not something you really want to know in detail about, let me add that at least sensitize yourselves to the way that vectors function and the way that word vectors function. Once you have that high-level understanding even, that in itself is sufficient for you to proceed forward with developing your applications. So let's get to understanding vectors. Hi, in my last video, I had started defining vectors and talking about their properties such as magnitude and direction. In this particular component, I am going to be talking much more about taking the concept of vectors and taking them towards word vectors, in fact. And we will see how words can translate very easily into concepts of vectors. All right, the first thing is I have over here on my right side a three-dimensional structure or a Cartesian coordinate three-dimensional structure with an x-axis, a y-axis and a z-axis. I also have a vector, and that vector consists of is for the word male, men. Now think of these x, y and z axes as representing different components of what it takes to be a man. One could be masculinity. Another one could be maybe, the fact that somebody, a little bit of patriarchy maybe. Another one could be, for example, a component of the physical appearance, maybe the height, the fact that men typically are taller. So these are just some random components I'm talking about. And typically in any word vector, you will have not 3 but thousands of such dimensions. All right, now let's understand a few other technicalities. The vector components. The components of a vector are the values along each of the axes. So for example, if we want to know the component of Y, which we take as masculinity, the masculinity component of men, we would drop a vertical line from the arrowhead to the y-axis, and from the from the origin to that line would be the masculinity component. The vector now, and similarly for the z component, it would be this distance, and for the x component, it would be this distance. Now, a simple way to think of it is the coordinates which you have, the numerical coordinates which you have in any coordinate geometry problem. The vector magnitude of the vector is the length of this vector, and it is defined in terms of its components using the Pythagoras theorem. All right. So a word can be therefore represented as a vector space as a numerical representation. I put a little small image of a word vector with thousands of components or dimensions. Now, word vectors and direction. What is a vector direction? The direction tells you where the vector points. Think of it as the angle it makes with a reference axis, like the x-axis in this particular graph. Two vectors are similar if they point in the same direction or are parallel to each other. For example, king and queen seem to be somewhat similar as they are pointing in broadly the same direction. Similarly, man and woman are also pointing in a somewhat similar direction. So they are somewhat similar. One vector could be shorter or longer than the other vector, and that represents basically the importance of the vector. The vectors represent words that have similar meanings or contextually related. For example, happy and joyful may also be vectors which point in a somewhat similar direction. Now, let's understand in a little more detail what are vector dimensions. First, let me talk about it not in the context of words, but in the context of a 3D object. I have here the xy axis, the y axis, and the z axis. And we have a point in this particular 3D space. A dimension is basically just typically specifies, and we typically specify its height from the floor, its length and its width along the floor to get the position of the object. A dimension is just therefore a quantification, as I've been saying, of particular aspects of an object which we want to measure in a consistent fashion. Let's take an object such as an apple and think about what possible dimensions can it have. The first is we would have 3 dimensions, x, y, and z, to define its position. All right. Then apart from that, we can also think of 3 more dimensions to capture its average color on the RGB, that is red, green, and blue scale. So each axis over here would therefore represent the red, green, and blue. And the actual average color of the vector would be some kind of average of these 3 scales, of these 3 dimensions. We can also add a further dimension for weight of the apple and for the height of the apple. So therefore, we've already, for the apple, just a simple little apple, we've got 8 dimensions we can potentially measure it on. We can generalize this concept to n dimensions. That is, there are n1, going from n1 to n dimensions. That's a bit scary to non-mathematical folk, but it just means that the number of dimensions is not specified. All right. Typically, as I mentioned again earlier, word dimensions, the dimensions on which word vectors are mentioned, is massive. You will have thousands and at times 10,000 dimensions. These dimensions are estimated from the data and represent the way, the subtle nuances of the way in which a word is used. It's captured by deep learning models. So it's something which is not particularly visible to us. We hypothesize about it. Now there's some other further properties of vectors which are important and which translate very nicely to the world of word vectors. For example, vector addition. Now vectors satisfy most of the properties and laws of arithmetic. Although it is important to note that these operations have somewhat different meanings in the context of vectors. A vector can be subtracted or added to each other in vector space. To add or subtract two vectors, you can add or subtract the two components. Let's look at an example in the image. We have two existing vectors. One represents the word happy, another one represents the word excited. All right. Now, the axes or the dimensions, we are just measuring these words on two axes. Maybe the first component might relate to emotional intensity, and the second component or dimension would be energy or positivity. Now, happy has a dimension of 2,4. That is, its emotional intensity is a little less, and it is actually higher on emotional intensity. And excited is less on emotional intensity and more on energy. If we add these components, we get the following vector, which is 3,9. That is to say 2 plus 1 and 4 plus 5. This vector we can possibly say is the word joyful, which is equal to happy plus excited. And this captures both the fact that it captures elements from happiness and from excitement. So I think that gives you an idea of why vector addition is important as a concept when we're talking about natural language processing. Another related concept is vector subtraction. Vector subtraction is done in the same way as addition. With one small change, we add the first vector to the negative of the vector that needs to be subtracted. So the negative is just a vector in the opposite direction. So over here, just observe, we have a vector A, a vector B, and vector B is going in this direction. So the A minus B vector, which is also a vector essentially, seems to have a direction somewhat akin to this. Alright, now let's look at a very famous example which has come up in natural language processing, and this has actually been validated and ratified by data extensively. It was found that the word vectors king, the vector for king minus the vector for man plus the vector for queen, woman, was found to equal the vector for queen. Which is absolutely amazing. Now, this essentially ratified the idea that there was a vector subtraction between king and man and addition of woman was taking place. Alright, so if you look at this image, for example, you have the vector for man here, the vector for king here, and the queen vector is here, and the woman vector is here. Now, king minus man means that the vector direction change from the king minus man changes slightly to have a vector which is slightly slanted in this direction. And when we add the vector of woman to it, it actually becomes closer to queen. So this is an example which has been found to represent vector addition. I hope you liked this video and it sort of enabled you to understand vectors and how they can be applied to word vectors a little better, and also made you realize that why it is important, if you're doing natural language processing, to have at least some understanding of this concept. In the next video, I'm going to be talking about how word vectors are actually estimated. So see you then.